Welcome back to the deep dive. Today, our mission is really about getting under the hood of modern cloud computing.
hmm
We've grabbed a stack of sources, the kind of baseline knowledge any pro cloud admin needs today.
Yeah, the fundamentals.
Exactly. And we're trying to pull out the absolute core nuggets. How do organizations actually manage, secure, and deploy applications at scale right now?
That's spot on. We're looking at what the industry sees as, well, mandatory for being competent. Forget the buzzwords for a minute.
Right.
We're focusing purely on how these cloud environments operate today. We'll hit automation for efficiency, some really high-level security stuff, and, critical network troubleshooting.
Okay, great. Let's unpack that.
Yeah.
First big theme, efficiency through automation. Because look, when companies move to the cloud, they hit a wall pretty fast if they don't automate management, right?
Oh, definitely.
Oh.
Manual doesn't scale.
So let's take a specific scenario. An admin's got containerized apps, think Docker, and needs a service that just handles deploying, scaling, healing, networking automatically. What's the term? What are they looking for?
Right. They need a container orchestration platform. That's the category.
Okay.
Tools like, well, Kubernetes obviously is the big one everyone talks about, or cloud-specific ones like Amazon ECS, they fit right in here.
Gotcha.
And this isn't just like a nice-to-have service. It's really the operational core for modern scalable apps.
Yeah, I think the key nugget here is maybe understanding where orchestration fits. Because you hear about IaaS, the raw VMs where you build everything yourself. And then you hear about serverless, where you just upload code and kind of forget the infrastructure.
Right, total abstraction.
So why is orchestration, the sort of middle ground, so vital?
Well, it solves a very specific problem. It tackles the sheer complexity of managing containers when you have a lot of them. Running one container, easy. Running, say, 1,000. You absolutely need a system ensuring they're healthy, traffic's routed correctly, scaling up, scaling down based on load.
Automatically.
The orchestration layer basically automates that whole container lifecycle. It takes care of all those tedious manual tasks, starting, stopping, linking them network-wise, restarting failed ones. All that happens autonomously.
The benefit seems obvious then. Less admin work, better uptime. But if orchestrators like Kubernetes are so powerful, why doesn't everyone just use them instead of, say, serverless? Is there a catch, a trade-off?
That's a great question. Because orchestration, well, it brings its own operational complexity. While serverless hides all the infrastructure, you literally just focus on your code. Orchestration platforms still need managing themselves, updating them, securing the underlying cluster.
Okay, so it's not zero overhead.
Definitely not. You get immense control and flexibility over your container setup, sure. But the price is that increased overhead, that complexity in managing the orchestrator itself. It's always that trade-off, isn't it? Power versus simplicity.
That makes sense. So this push for automation, it doesn't stop once the app is running, does it? It has to go right back into the development process itself.
Absolutely, end-to-end.
Let's shift gears then. How do companies speed up getting code from a developer's machine into, say, a staging environment? We're talking about an automated pipeline. Build, test, deploy every single time someone commits a change to the shared code repository.
Okay, what you're describing there is really the heart of DevOps. It's implemented using continuous integration and continuous deployment. CI/CD.
CI/CD, heard it a million times.
Yeah, it's basically that automated conveyor belt. CI integration means constantly merging and testing code changes, catches errors early. CD, deployment, means automatically packaging that tested code and shipping it out to the staging environment or even production sometimes.
And the big deal here isn't just the automation, it's the reliability it brings, right? Forcing that build and test on every little change must cut down on big problems later.
Totally. The speed is great. Everyone loves speed.
Yeah.
But that reliable consistency, that's the real strategic win.
Right.
And we should probably distinguish CI/CD from another buzzword often used alongside it, infrastructure as code, IAC.
Okay, good point. Let's clarify. If CI/CD is like the delivery truck for the app, what's IAC?
Good analogy. Think of IAC as the blueprint and the robot construction crew that builds the whole environment first.
Ah, okay. The roads, the buildings.
Exactly. The VPC, the subnets, the databases, firewalls. IAC automates provisioning the infrastructure. CI/CD automates delivering the application software onto that infrastructure.
Got it. They work together.
They really need to work hand in hand. You use IAC to create those consistent, reliable environments that CI/CD pipelines depend on to work properly. One builds the stage, the other puts the actors on it.
Okay, that clears it up. So we've covered speed, efficiency. Let's talk security, because you need controls that keep up with that speed.
Absolutely crucial.
Let's move to what you might call the gold standard for protecting data. Imagine a company with super sensitive info, patient records, maybe financial secrets stored in cloud object storage like S3.
Right. High stakes.
And their security team has a very strict rule. Data must be encrypted before it even leaves their application, and only decrypted way later by the application itself when it retrieves it.
Okay, that specific requirement encryption, controlled only by the data owner, starting before the cloud, that points directly to client-side encryption.
Client-side encryption.
Yep, it's arguably the highest level of technical security you can get because you completely remove the cloud provider from the circle of trust for the actual data content.
And the why is key here, isn't it? Why bother with that extra effort? All the big cloud providers offer pretty robust server-side encryption, don't they?
They do, and server-side encryption is great. It protects against, someone stealing a hard drive from the data center or unauthorized access within the provider's systems.
Okay.
But with server-side, the cloud provider still holds the encryption key, or at least controls the system managing the keys. They could potentially decrypt the data. With client-side encryption, your organization manages the key. The data is encrypted before it even hits the cloud network wire. The provider never sees the plain text, ever. It's fundamentally zero trust for your stored data.
Okay, but hold on. If that's the gold standard, the absolute best, why isn't everyone doing it for everything? Seems like a no-brainer for security.
Yeah, it does seem that way initially.
But doesn't managing those keys yourself create a huge risk? Like, what if the company loses its own key? That data's gone forever, right?
Yeah.
Even the cloud provider can't help.
You've absolutely nailed the central tension. It's maximum security versus operational reality. Key management becomes entirely your problem. And that's not trivial. Securing the key systems, ensuring they're backed up, rotating keys, handling potential loss.
Yeah.
It's a massive operational overhead.
Right. A big responsibility.
Huge. So for many companies, unless the data is incredibly sensitive or there are strict regulations mandating that kind of customer control, the trade-off just isn't worth the hassle and risk. That non-technical burden often stops it from being used universally.
Wow. That's a really important strategic point. Okay, shifting from prevention, what happens when security fails? Because inevitably, sometimes it does.
Unfortunately, yes. Incident response time.
So a security engineer needs to figure out the exact sequence of events, like step by step. What happened? Who did what? When? All the system and user activity that led to a breach on a virtual machine. What's the primary source for building that timeline?
For that kind of forensic deep dive, needing the low-level play-by-play, you absolutely need system audit logs.
System audit logs.
They are the essential source for understanding the precise progression, the chronology of an attack.
Let's make that distinction clear. You've got other logs, right? Network firewall logs, maybe application performance monitoring data. Why are audit logs the key for that chronological reconstruction?
Think of it like this. Network logs might show you who knocked on the door or tried to connect.
Okay.
The audit log is like a full transcript of everything they did and said once they got inside or gained access to the system.
Ah, the detail.
Exactly. Audit logs, record-specific, low-level actions. Every file they try to access, config changes they made, commands they ran, logins, attempts to escalate privileges.
What?
All time-stamped.
Right.
That granular detail lets you rebuild the exact timeline the incident response team needs. Without that sequence, you're just guessing at what really happened.
Makes perfect sense. Okay, we've hit automation, we've hit security. Final area. The absolute backbone networking and troubleshooting. This is where cloud engineers often live day to day, right?
Oh, yeah. That would keep people busy.
So let's take a common, really frustrating scenario. A network engineer is trying to fix a connection problem. It's between their company's private network on-prem and their virtual private cloud, the VPC.
Hybrid setup.
Right. The overall VPC seems okay. The connection seems configured properly, but one specific subnet inside that VPC just cannot route traffic back to the on-prem network. Everything else works. Just this one subnet is black holed for return traffic.
Oof. Yeah, those are annoying.
Where's the first place that engineers should probably look? What's the most likely culprit?
Okay, if it's that granular, just one subnet affected, not the whole VPC connection, and assuming the main routes look okay, the prime suspects are almost always the network access control lists, ACLs, and security groups.
Like ACLs and security groups. Why those specific granular rules first, rather than maybe the main routing tables or something on the VM itself?
Because ACLs and security groups act like internal traffic cops within your VPC, they operate separately from the main routing that gets traffic to the VPC.
Okay, they're like filters inside.
Exactly, they're filters. And when they're misconfigured, they can easily override broader network rules and create these weird, often asymmetric blockages. Traffic goes out fine, but can't get back in, for example.
Right.
And the key insight here, maybe the deeper point, is understanding why you have both. ACLs operate at the subnet level. Think of them as stateless firewalls for everything entering or leaving that whole subnet boundary.
Okay, subnet level, stateless.
Security groups, on the other hand, are stateful firewalls that attach to individual instances like your VMs.
Instance level, stateful. Got it.
So an ACL might block, say, all return traffic on a certain port for an entire subnet, isolating it completely from on-prem. Meanwhile, a security group might just be blocking SSH access to one specific server, even if the rest of the subnet can talk just fine.
So they provide that layered defense, that segmentation within the VPC.
Precisely. They're essential for isolated environments, like keeping databases separate from web servers. But yeah, if just one rule is wrong, or maybe accidentally deleted, it's probably the most common reason for these baffling internal routing failures inside the cloud.
And especially that asymmetric thing you mentioned.
Oh, yeah. You see it all the time. Outbound works. Inbound gets dropped by a stateless ACL rule the engineer forgot about. Drives people nuts. Checking those specific controls first is usually the fastest path to fixing internal connectivity glitches. So here's the question maybe for you to chew on. If client-side encryption is technically the best, what operational or maybe legal or even financial challenge do you think most often stops big organizations from just using it everywhere?
Good question.
It's really that constant battle, that tension between pure technical security and the realities of operational cost and complexity. That's what drives so many real-world architectural choices.
That's a perfect place to leave it. Now you've got the core knowledge, hopefully, to navigate those kinds of discussions and make better decisions about building and securing cloud apps. Go forth and apply it.